When a car is broken, you take it to the mechanic. In order for the mechanic to fix the car, they must first understand the intricacies of the engine. Now, one may draw parallels between the engine of the car and the brain within the body. In order for us to understand the neurological pathologies related to the body, we must first understand the intricacies of the brain, which governs movement, cognition, and homeostatic control of every organ system. Now, despite extensive research over the last century outlined by Zhang et al., complete comprehension of the functionality of the brain still remains unknown. Hello, my name is Georgia.
And my name is Claire.
And we are super excited to present our prosection idea for the 2020 MERF Commission.
In the early stages of planning our prosection, we surveyed 10 students who had previously undertaken a first-year anatomy unit here at QUT. These results indicated that the majority of students found the brain to be the most difficult and complex region of the body to learn. Therefore, our proposed prosection will divide the cranium into 5 axial sections, which will enable students to visualize the key structures of the brain in situ on both the superior and inferior sides. Now, let's take a closer look at our 5 axial sections.
Most superiorly in Section 1, students are able to visualize basic anatomical structures, including lobes of the brain, functional gyri and sulci, as well as the falx cerebri. Moving inferiorly, Section 2 allows visualization of the superior aspects of the anterior horn and body of the lateral ventricles, as well as portions of the head and tail of the caudate nucleus.
The inferior surface of Section 3 highlights the subcortical nuclei of the forebrain and structures within the diencephalon, considered to be the most challenging yet important regions of the brain. Students will visualize the basal ganglia, located lateral to the third ventricle, and the thalamus and internal capsules, located posterolaterally. Additional visualization of surrounding structures, including the internal capsule, insular lobe, and fornix, will provide an ideal view of structures located deep to the cerebral hemispheres. A significant feature of the superior aspect of this section is the ability to view the dimensions of the basal ganglia and the thalamus of the right hemisphere. By sculpting the perimeter of the basal ganglia and thalamus, we will accentuate the location of these structures within the brain.
In Section 4, structures of note include the internal carotid arteries and the basilar artery. Additionally, the optic chiasm will be made visible through sculpting techniques. And finally, most inferiorly in Section 5, students can observe the vermis of the cerebellum located posteriorly to the medulla oblongata of the brainstem. To prevent the cranium from deviating from its position within the vise during axial sectioning, the skin, superficial fascia, and facial muscles of the cranium will be removed. An additional 3 mm was reserved to account for tissue damage due to friction from the bandsaw.
The axial sections will be displayed on clear plastic trays and sealed within a clear plastic sleeve for ease of handling by demonstrators and students. This will preserve the structural integrity of the prosection and eliminate the need for the use of a wetting agent. Unlike many other prosections, the display of these axial brain sections is not limited by the availability of fume hoods. This exponentially increases the accessibility of this prosection at QUT undergraduate labs, where the availability of fume hoods is very limited.
Our axial sections are an excellent addition to the QUT human donor collection, as they are relevant to at least 7 health units. They can be employed as a teaching resource in all first-year anatomy and physiology units. In more complex units, the application of our slices are crucial as they correspond to the CT and MRI images. These axial sections will also be an invaluable teaching aid for more advanced anatomy and physiology units, where it is emphasized that structure equals function.
Human cadaveric material demonstrates anatomy in its most basic form. Without this raw interaction with the brain, we could not hope to have made any major scientific breakthroughs. While plastic models can provide a rudimentary understanding of anatomy, not allowing students to have the opportunity to interact with the brain through tangible human cadaveric material denies them the opportunity to make the same scientific strides. Considering there are no current axial sections available in the QUT human cadaveric collection, we believe that this would be a very worthwhile addition.